Number 1 says rename each mixed number as an equivalent mixed number with the same denominator. So if we look at the first one, we have 7 and 5/3. So if I look at this 5/3 right here, I know that I can change that into a smaller number because 3 goes into 5 one time with 2 left over, and the denominator stays the same. I already had 7, so now I need to add them together. So it would be 8 and 2/3. For the next one, 4 and 6/9, I look at 6/9, and I see that I can't simplify that anymore if I want to keep it the same denominator. However, I can take 4 and I can make that into 9ths. So if I do 9/9 plus 9/9 plus 9/9 plus 9/9, that's 1 whole, 2 whole, 3 whole, 4 whole, plus 6/9, I can play around with it. So maybe I'm going to keep this as 3 wholes, but I'm going to take this whole and add it to my 6/9 to make an improper fraction. 9 plus 6 is 15, and I'm going to leave that denominator the same. So I could change it to 3 and 15/9. For the next one, for C, it's 3 and 7/8. It's the same thing. 7/8 I can't change into a mixed number, so I can take my 3 and turn that into 8ths. So 8/8 plus 8/8 plus 8/8 is the same thing as 3 wholes. And then I have my 7/8. So I'm going to keep these 2 wholes, and then I'm going to change 8/8 and 7/8 into an improper fraction. So 8 plus 7 is 15, and I'm keeping my denominator the same, so we can change it into 2 and 15/8. For D, I have 5 and 19/14. Since I look at 19/14, I know 14 can go into 19 one time with 5 left over. My denominator stays the same, and I already had 5 wholes, so now I have 6 wholes and 5/14. There are different answers for these ones. If you wanted to, again, just keep 1 whole here and add all 3 of these together, or vice versa for any of them, that would be fine. Number 2 says write each of the following decimals in words. So we start here. It's 18. We say and for the decimal point. And then we look, we have 4. And it's not in our tenths place, it's in our hundredths. So 4 hundredths. The next one, we look at our whole number, which is 814. Then we look at our decimal point, so we say and. We have nothing in our tenths, and then we have 17. And since it ends in our thousands place, we say thousands. Number 3 says Hannah and her brothers equally split the cost of a $379 gift for their parents. How much did each sibling pay? So, again, we have $379, and it's split between Hannah and her 3 brothers. So it's split 4 ways. So we have to divide it by 4. 4 cannot go into 3. However, 4 can go into 36 9 times. 9 times 4 is 36. Subtract 1. Bring down. 4 goes into 19. 4 times 4 is 16. We subtract. That's a 3. We have nothing else to bring down, so that's our remainder. So we know that each sibling paid $94, and then we have $3 left over. So we're going to split that $3 again into 4 people. So our remainder is 3/4. So each sibling paid 94 3/4 of a dollar. What did we do with the remainder? We reported it as a fraction because, again, you can't not pay the people the extra $3, so you have to split that $3 by the 4 people paying for it. Number 4 says Mindy needs 3 1/3 cups of raisins for the trail mix she's making. She only has 1 2/3 cups of raisin in her pantry. How many more cups of raisin does she need? Show your work. So if we look here, our important parts are this 3 1/3 and 1 2/3. So we know we're going to have to do something with those numbers. Then we look at the problem. It says how many more. Anytime we see how many more, we know we have to subtract. So our number model would be 3 1/3 minus 1 2/3. So then we need to actually solve it. So if we have 3 1/3 all of these are shaded, and 1/3, and we need to take away 1 2/3. So we're going to take away 1 whole, and then we need to take away 2/3. So we're going to take away this third, and we're going to take away this third. So how many does she have left? She has 1 whole and 1 2/3. So Mindy needs an additional 1 2/3 cups of raisins. The last one says plot the following points on the grid and then connect them in order. So we have 0, 1, which is right here. Then we have 1, 3, 4, 3, 5, 1, and then 0, 1. So we have drawn a trapezoid.